The kinetic molecular theory, which is what the ideal gas law is based on, relates the macroscopic properties of a gas, being pressure, volume and temperature, to the motion of the particles in a gas, which is typically velocity or speed. And the key assumptions of the theory are that the particles of the gas are in continuous random motion. The collisions between the particles and the walls of the container are elastic, meaning that energy and momentum is conserved. So there's no dissipation or losses in the collision. And the volume of gas particles is negligible compared to the volume of the container. There's no attractive forces between the particles, so the intermolecular forces are negligible. And the particles can be that of a monatomic gas, such as helium, a diatomic gas such as oxygen, or a gas molecule being water vapor. So under certain conditions, the intermolecular forces are negligible. Now the average kinetic energy of a single gas or a gas mixture is proportional to the temperature, which is the absolute temperature in Kelvin. And basically for a mixture of gases at a given temperature, the entire mixture has the same average kinetic energy. Now using this equation for the kinetic energy of a single gas particle, the average kinetic energy of a particle can be related to its average velocity. And here we typically use standard international units, so kilograms for the mass, meters per second for the velocity, and the kinetic energy is in joules.